class. Welcome back to the wireless and mobile communication online lectures. We are starting the lecture number 3 for the first week. I hope everyone is fine and have gone through the first two lectures. Before starting, let me quickly summarize what we have discussed in our last lecture. In our last lecture, we talked about some fundamental concepts related to the wireless communication, and we discussed that wireless communication is established through transmitting electromagnetic wave through the free space. So the transmitter antenna transmits the electromagnetic wave corresponding to the incoming signal, and the receiver antenna captures that electromagnetic wave and convert it back to the electrical signal and deliver it to the receiver. And in this way we are able to establish the communication between transmitter and receiver. Secondly, each communication channel is established at a specific frequency. So in order to have multiple communications simultaneously, we need to have different channel, and eventually we transmit our signal at different frequencies so that simultaneous communication can be established between different antennas. While talking about the architecture of wireless communication systems, we discussed that from the user perspective, the main component is user equipment. The user equipment not only provides the interface to the user, but also it has the capability to establish communication with the base station. So the user equipment is actually it has the capability of taking input from the user, convert it and process it to the electromagnetic wave to transmit it to the connecting base station. The base station that is connected to the user equipment is on the other side. It's connected to mobile switching centers. The mobile switching centers, they provide connectivity to PSTN as well as other mobile switching centers in different areas. In this way, we are able to establish communication over a wider area by connecting various mobile switching centers and controlling the communication through those mobile communication centers, mobile switching centers. Sorry. Let us now come to our today's lecture. In today's lecture, I'll be talking about the evolution and some examples of wireless communication systems. While I would recommend all the students to read the sections 1.1 to 1.4 of our textbook, that is the Rappaport's book, that sections provide some introduction regarding evolution of wireless systems. Of course, we will be discussing briefly those evolution in this lecture today. In conjunction to wireless communication, a commonly used term is personal communication services, or PCS. So let me start with defining PCS, personal communication services. Actually, this term is used for wide variety of networks in which we have wireless access as well as the mobility for the user as well. And you can see that this type of services, they are available in variety of different applications. For a simple application can be our cellular phone. It provides the mobility to the user as well as it provides wireless access to provide communication with the base station or other users. Another example can be cordless phone that are also commonly used in variety of places. Cordless phones also have wireless communication established with the base equipment, and also they provide mobility to some extent to the user. So typically these PCS services, they are provided using a small terminal or a small device. For example, for mobile phones, your mobile device is that terminal which is used for for this to establish that PCS communication. And intent of having this PCS communication is that you are able to communicate at any time, at any place or any form. And you can see that for such a communication system we have a tremendously big market. You can compare the cell phone market in today's world. You can see that it's a very large market, and there are number of users that are available for this market. PCS systems are generally characterized as high tier systems or low tier systems. High tier systems are those which are which provides variety of different services and mobility to the larger areas. For example, GSM systems, IS 136 and other cellular systems that provide communication over a larger area, and it provides relatively more flexibility to the user as compared to the low tier system, which generally provides connectivity to a relatively smaller area with some limited functionality. You can take the example of cordless telephones and its variants, the digital enhanced cordless telephone and other services which provide communication to relatively smaller area, and it has limited functionality as compared to the high tier systems. The evolution of PCS systems is basically is very important. Generally, these PCS services were started to establish voice communication at different places. Generally, we want to have voice communication between two different users which are using PCS services. But of course, in some cases we also want to establish the communication between the traditional public switch network, PSTN, or voice network. So the PCS systems, the one task for PCS system was to integrate those PCS services with other voice services, and eventually that led us to the cellular mobile telephone system that we will be discussing in today's lecture as well. Secondly, there is need of having data networks. We want to use data and internet access to our devices, and eventually we want to integrate these PCS services to establish a data network as well. And third important thing, which is actually the goal of third generation of wireless phone and all above generation, fourth and fifth generations, we want to integrate all the services together. We want to have voice communication over same network, we want to have data communication over same network, we want to have multimedia services over same network. So basically in today's world we want to integrate all of these services in same network, which was achieved in actually third generation of wireless systems. And okay, so you can see that there are two important aspects in which we try to integrate our services. First one is the voice communication, and second is of course the data network. So basically this is a field where we have some overlap between the voice services and the data. You can see how we view these services. The telecom people, they think of telephone services, and we want to integrate those services with the traditional public switch network, telephone networks. When we talk in terms of data networking, those in data networking, the data networking people, they think about integrating the mobile services to the internet. So eventually at the back end they want to connect all the services to the internet. So this is the overall scenario. There are some common things between telecom interest and data networking interest. When we talk about telecom, so eventually we are considering the voice transmission. We are focused on frequency reuse, handoff management, location tracking, roaming, and all other services which are common to the telecom perspective. Similarly, when people talk about the data networking, people talk in terms of data networking. Eventually, they have other priorities, like how to transmit the data, how we need to integrate the mobile with the internet, that is the mobile API, how we can establish ad hoc network, and how we can provide other relevant services. And in doing so, because we are trying to have these services integrated through a wireless link, so eventually in both cases there is a common scenario, common area of interest in which we talk about the wireless connectivity. In those areas we generally talk about the radio propagation or propagation of electromagnetic waves from the free space. We talk about the characteristics of the link that is established between two nodes. We talk about the errors that are being occurring in those transmission, or how we can control those errors. We talk how we can access the wireless medium, and similar questions are discussed. So basically there are two sides of services, telecom and data networking, which are interrelated to each other. So of course from telecom perspective, we will be in this course we will be discussing the services that are more related to the telecom side. So if you talk about some examples of PCS systems, you can see there can be variety of PCS systems, including both low tier and high tier systems. You can take the example of cordless telephones, cellular telephony, which is now commonly used in our daily life. Wide area wireless data systems are also used in different application. We can use these PCS services as local and personal area networks. Paging systems is another example of PGS systems. Satellite based mobile systems are also PCS systems which provide connectivity for personnel with some mobility. 3G wireless systems and beyond, they also provide different options to the PCS system and integrating all the services that are commonly intended for such users. This table provides a summary of radio standards that were established in United States of America. This table is extracted from the textbook. It's table 1.1 of textbook. The initial standards were AMS phone, ASDC phone, CDPD phone, IS-95, which were actually cellular. All these were cellular services. Flex was a paging services that was used in US. The GSM was also one of the services that was established in US, and PACS services or cordless phones were used in standardized in USA. The relevant data is provided in the table. Similarly, there was parallel development going on in Europe side as well, and there were services that were established in European countries. This table provides a summary of variety of different services that were established in Europe. Again, this table is extracted from our textbook, which is table 1.2 of the textbook, and it summarizes the major mobile radio standards that were developed in initial days of wireless evolution in European countries. So again, you can see that there are cellular services as well as paging services and cordless services that were established with different, of course, channel bandwidth and different modulation techniques. So let me talk about cordless telephony. Cordless telephone systems are actually they provide full duplex communication systems. Actually, generally a cordless telephone system, it is established as in two different units. One is the mobile unit and second one is the fixed unit, which serve as the base station. You can see from the diagram here, we have a public switch telephone network which is connected to which provides services to the fixed unit of the cordless phone, and that fixed unit is actually wirelessly connected to the cordless handset. So this cordless handset provides mobility to the user, while the base station or the fixed unit is actually remains fixed at certain location. Typically, this cordless phone is characterized by low mobility, because the wireless phones is generally intended for establishing in-home mobility or mobility to a relatively smaller area because of the low power consumption or low transmitted power by the base station. So basically this characterized by very low power consumption. The good thing is that it provides two-way communication, means it's a full duplex communication because of the is dedicated terminal, dedicated base station and dedicated cordless the mobile handset. Generally circuit qualities, they are very high, the equipment cost is low, and these equipments, they can be used for longer talk time. Generally one cordless phone is actually connected to the one base station, so eventually we do not need to hand off with different base units. So one unit remains fixed with dedicated to that particular base unit. These cordless services were initially developed as analog devices, but eventually these were transformed into digital services, and later on we used to have digital cordless devices. As I said, the cordless telephones, they are intended for use at home or public places where base units are available, but eventually they have smaller range. Design choices, if we talk about design choices of the cordless phone, so they can only support few users in the region. Eventually, because we need dedicated base units for each device, so we generally need large number of base units per usage area. Transmission range is small because transmission power is also very small, so generally this cordless phone, they are used for like tens of meters range. The complexity is relatively low because of the simple network and dedicated hardware. Generally we do not need forward error correction in this system, and because of the low mobility and low transmission range, the transmission delay is also very small, which is of the order of 50 milliseconds. Another PCS system is actually paging system. What is paging system? Paging system is kind of a broadcast system that is used to send brief messages to subscriber. Generally, a message is sent to a paging subscriber via paging system access number, which is input using a keyboard. That message which we use to transmit to the subscriber is known as page. So generally what happens, if we need to transmit an information to subscriber, the paging system transmits the page throughout the service area, and this is generally transmitted from all the base stations which are services in that particular area. Generally these paging receivers, they are simple and expensive, but the transmission system, they are relatively costlier and sophisticated. Because the intent of using the paging system is to transmit the information over a larger area and provide information, send that information simultaneously to many subscribers. Generally the paging system controller, it gives the information to the base station, all the base stations available in that region, and those base stations, they simultaneously broadcast the information that is received by each subscriber. This is called simulcasting, because the information is simultaneously transmitted in the region. Simulcast transmitter, they may be located in same city, they may be located in different cities, or sometimes they may be located in different countries. Paging systems, the good thing about paging systems is that they are reliable, and they are good for establishing sending quick messages to the subscriber. One important thing is that because we want to have high reliability as well as the maximum coverage for paging systems, so we need to have large transmitters, large transmitting powers that is being transmitted from the transmitters. So typically the power that need to be transmitted from each base station is of the order of kilowatts. However, the data rate, they are relatively very low. They reach up to maybe couple of thousand bits per second. So we work on very low data rate for such paging system. This diagram actually illustrates the working of paging system. We have a paging control centers which transmits, which controls the paging information, and eventually it provides that information to all the paging terminals which are available, you can think of those paging terminals at the base station as at different locations. These paging terminals then transmit the information to all the subscriber in that particular region Okay, so these were two examples of low tier PCS services. Now let us move to high tier PCS services, which is actually cellular telephone system, which is the topic of next few lectures. Maybe we'll be talking about details of cellular telephone system. If you recall quickly, we need to use different frequencies for transmitting signals over different users. So eventually, because we have a limited frequency band, so eventually we end up with the problem that we have because we have limited frequency band, so we can simultaneously connect limited number of users, and we may not be able to add more users when the frequency band is fully occupied. This problem was addressed in cellular telephone system. The concept of cellular telephone system is, you can say that it revolutionized the cellular telephony, the telephony that we use, the mobile telephones that we use. They are now based on this cellular concept. Let me quickly describe the cellular architecture here. So what we do, we divide the entire coverage area into smaller areas which are known as cell. In the figure you can see that there are hexagonal areas identified, and each area you have a base station. So actually one base station is responsible to provide coverage in that particular service area, which is a cellular, which is a hexagonal area, which is known as cell in modern terminology. Uh, and you can see that when we are at two different cells, that means the coverage can be extended by reusing the frequency. So if one mobile station is transmitting at a frequency of 800 megahertz in one cell, so its effect on the other cell, because of the larger distance and low power, will be smaller as compared to the base station which is present in that particular cell. So if the distance is relatively large, we can reuse the same frequency. So if 800 megahertz frequency is being used in one cell, we can use the same frequency at another cell, and so on. So eventually this frequency reuse concept, it allows us to increase the overall capacity of the network. However, while doing so, we end up with another problem, which is known as handoff, because each base station is responsible to provide coverage in a particular area. So if due to mobility one user moves from one cell to another, its call has to be transferred from one base station to the other base station, and this transferring of the call is known as handoff. So cellular telephony requires handoff as well. So generally, if we characterize the cellular telephone system, the important aspects of wireless telephone, cellular telephone system, first thing is that it can provide high mobility. Second, it can provide coverage to the wide area because of the presence of various mobile stations. It can be used for two-way wireless communication system. Similarly, we need handoff and roaming support in that services, because users may switch between may move between one cell to another, and eventually its call has to be transferred from one base station to other. We need to integrate this cellular architecture with the PSTN, which is generally established at the MSC. Generally, we need this cellular system. They require larger transmit powers of the order of 2 watts from the handsets. Okay, so mobile, if from mobile user perspective, we need to use very complex circuitry and design for the cellular circuitry, because we need to incorporate a variety of different protocols in those mobile devices, where those circuitry should support handoff flexibility, it should support the connectivity at different frequencies, and so on. There are various functionalities that are required to be incorporated in those mobile equipments to be used in cellular telephone system. Base stations, they actually they are the gateways for the cellular telephone system, because at the front side they are connected to the mobile equipment, which is providing the wireless connectivity. So at the one end it's having a wireless connectivity with the mobile equipment, and at the other end it's connected with the wireline link to the mobile switching centers. So the back end of the mobile station is actually connected with the mobile switching stations, and eventually it has to provide connectivity with the MSCs as well. So basically these base stations are connecting these wireless and wireline links in a same network. And as we have already discussed about mobile switching centers, they connect different base stations and different mobile switching centers and PSTN to establish a terrestrial telephone network. This is a simple curve representing the growth of wireless subscriber in the world. Some number of million subscriber. You can see that initially the number of users, they were growing at very rapid range because the market was because of the gap in the market, because very few users were having mobile phones at that time, and new users were getting mobile phones. And now in the year 2020, this market is about to is going towards point of inflection, or towards saturation, in the way that most of the subscribers, they already have subscribed to the some sort of mobile services. So the number of addition of number of subscribers is relatively smaller, as we witnessed in last decade. Okay. Next, I'm going to talk about wireless system evolution actually, and for that I have prepared a PDF file that I am going to share with you, and I will share through Google Classroom as well. So this is the file. The wireless generations, they evolved over the years in past few decades. The first generation was, you can say, you can call it a 0G generation wireless technology. In 0G, there were radio telephones, but uh, uh, they used to connect to only one base station. There were no cellular concept, and no concept of mobility or other such services. The true evolution of wireless system evolved started from the concept of cellular network, which we generally called 1G communication, first generation of wireless communication. Those were actually analog telephones, and which were established, basically the first time it was launched by Japan in 1979, and then in 1984 Bell Laboratories developed the commercial cellular technology, which employed multiple centrally controlled base stations, and each base station was providing service to a smaller area or a smaller cell, and those smaller cells were connected together to provide a coverage over a large network. So this evolution of the concept of cellular system sparked the development of wireless technologies, and rapid growth of subscriber in the system. The primary features of wireless first generation of cellular system was that they were actually analog systems, and primarily they were using analog modulation. Most of the systems at that time were actually focusing on frequency modulation. The mobile network that was established at that time in United States was named as Advanced Mobile Phone System, AMS, which were utilizing the frequency spectrum of 800 to 900 megahertz frequency. The main channels that were employed were basically frequency channels. So basically the duplexing was achieved through frequency division duplexing, and the multiple access was also frequency division multiple access in those systems. Primarily those networks were designed for voice traffic. So eventually those systems can only be used to provide voice connectivity between two users, and there was no support of data at that time. The second generation of wireless cellular communication is attributed to the emergence of the digital networks. So primary standard that was developed in that era was known as GSM, or Global System for Mobile. The GSM phone were basically digital phone. They introduced the digital transmission, and of course, as we know that the digital transmission, they have certain advantages over analog transmission. So eventually those digital phones, they provided such advantages as compared to the mobile the analog telephony available in first generation. Some of the benefits that we witnessed in the 2G was that it was basically, because it was digital signaling, it required lesser power as compared to analog signaling. So that affected the battery life. So you were able to use the batteries for longer time. Digital coding techniques, they improved the voice quality and also help reducing the noise in the line. Digital signals are considered environmental friendly, and secondly, it's much easier in digital systems to incorporate encryption. So basically, those digital systems increase the security and safety of data and voice in those networks. The use of 2G technology requires some strong digital signals to help mobile phone networks properly, is the same thing that we've discussed. Okay. The second important thing that was introduced in second generation was the short messaging services, or SMS services. So basically, this text messaging provide an alternate way of communicating with each other. People was able to establish communication through text messaging rather than having the voice calls between two subscribers. And in many markets, we know that many people, they prefer text messages as compared to the placing voice calls. The further evolution in second generation was inside of data communication. There were new technologies that were introduced to increase the data rate provided by those cellular systems. First was GPRS, or General Packet Radio Services, which is typically named as 2.5G. It was a technology which developed to support to provide the data rate at ranging from 56 kilobits per second up to 115 kilobits per second, and with that we were able to have many other applications such as multimedia services and other services, and also we were able to integrate with the internet. Then edge services, which is the abbreviation of enhanced data rates for GSM evolution, which is sometimes referred to as 2.75G. Edge technology is extended version of GSM, which provides even higher data rate of up to 384 kilobits per second speed. After the second generation of mobile phones, cellular technology, we eventually had moved to third generation mobile technology. The main technological difference between 2G and 3G was that in 2G the switching was based on the circuit switching. So basically there were physical circuits available which provide the switching between terminals, and those switches were used to connect different devices. In 3G, those switching circuits were basically replaced by packet switching. So that packet switching made it more flexible, the data transmission more flexible, and the integration with internet become much easier as compared to the 2G communication. In mid of 200s, the evolution of 3G technology began to be implemented, and the technology was named as high speed downlink packet access, or HSDPA. It is actually enhanced 3G mobile telephone communication protocol, which sometimes named as 3.5G or 3G plus or turbo 3G, which allows the network services, new network services, which were named as Universal Mobile Telephone System, or UMTS, that were able to have relatively higher data transfer speeds and relatively higher capacity for the networks. The HSDPA developments supported downlink data rates of 1.8 up to 1.4 megabits per second, and then further evolution to HSDPA plus was provided data was capable of providing downlink data rate up from 42 megahertz up to 42 megabits per second to 84 megabits per second. The next generation of mobile communication, which is generally named as 4G or LTE or WiMAX, these are evolved versions of actually 3G, in which the data services become broadband services. So eventually we end up with mobile broadband in 4G communication. So basically the 4G, they have they can support high quality audio and video streaming over internet protocols. One of the main way in which the 4G differed technologically from 3G was in its elimination of circuit switching, instead employing all IP network. So the entire network was based on internet protocol. So basically having those internet protocol made a seamless integration with internet and voice and all types of services into one single platform. The 4G LTE data transfer speeds were able to reach up to a downlink speed of the order of 100 megabits per second, and upload speeds were of the order of 50 megabits per second. And for LTE and for WiMAX, those were 128 megabits per second downlink and 56 megabits per second uplink. Under 4G, users were able to experience better latency. That means there were less buffering for different services, higher voice quality, easier access to the instant messaging services, social media, quality streaming, and made faster downloads. And now we are in the era which is associated with the development of fifth generation of mobile telephony, which is actually we are going towards Internet of Things. We are going beyond connecting different subscribers with each other. Actually, we are now thinking of connecting various devices to each other, and these these 5G technologies, they are capable of handling large amount of data as well as a variety of different services in a single platform, and will be able to connect various of different devices through various of different protocols that are integrated together, eventually to provide a larger coverage. So this was a brief overview of the evolution of wireless technology. This technology evolved from 0G up to the 5G over a span of around like half century, and we are still in the development phase. Currently there is a tremendous amount of research work going on throughout the world in further enhancing all those technologies which are useful for having such services, integrated services at different points. So I think this is enough for today's lecture. So I'll stop here. We will be discussing the cellular telephony in subsequent lectures as well. So I'll take your leave. You guys have good weekend. Thank you.